Hey, my name's Akil Ra. I'm the CEO and co-founder of Abstraction AI. And I'm just going to be walking through a quick little demo of our entire platform here. So what you see here is our homepage. This is basically a visualization of all your different models that you've created, all your different agents. You can see metrics like model ID, created, last updated, stage, etc. Obviously, because of the beta, we're beta URL that I'm working off of right now, have not populated, but you'd be able to see a lot more granular level of metrics. So we have two workflows. One is a RAG as a service. So this is basically a 5-step workflow where you'll be able to create a knowledge base, be able to upload files. We automatically build a RAG pipeline based off of your specific configuration. And then once you've gone through that, you'll be able to do model validation. So we have up to 3 different models you can call in unison. And basically just be able to test, validate pretty quickly, tune some smaller parameters here, and then be able to integrate that. Once you're ready to actually push into production, we give you a code base for said model that you can then integrate back into your front end or back end. So what's more interesting and what I actually want to showcase here is basically our agent orchestration workflow. So we're at our core a compute engine and a inference layer for all of the architecture that you actually built. So we allow our users to quickly just spin up various different applications. So I'm actually going to grab out 4 different nodes here, and we create a very um, low effort required UI for our customers to basically quickly experiment with, validate, and then push to production. So you'll see here I have 4 different nodes that I'm basically just playing around with. And what I'm going to be able to do is basically build a solution for a common pain point in the provider payer landscape, which is contract negotiation when it comes to finding the most optimal payer to bill for providers. So what we're going to do here is I'm actually, for the sake of time, pre-built prompt templates that I can just drag and drop. So you can see here it's auto-populated with my specific prompt. I'm going to do the same for node 2 here. And I'll zoom in just a little bit once I've created all these prompts just to show you what the functionality is. So if we go here, this particular function is basically taking aggregate claims data, identify patterns, and then evaluate provider performance metrics. So I'm going to be passing in a JSON, and the model is basically going to run this actually in parallel with this inference node here. And you'll see here that this is responsible for analyzing historical authorization requests, identify approval rates, common reasons for denials, patterns, etc. What we're really trying to do is pattern map and basically take this claims data as well as provider specific data and really try to find out where the provider is missing out with regards to what the payer is offering. So now is where I can actually indicate that the outputs are going to be passed in parallel. So both of these are going to be run in unison, passed into my third node here, which is basically responsible for doing cost and quality analysis. So basically taking the cost of care based on claims data, evaluating the quality of care based on authorization data, and then I starting to identify trends and areas of improvement. Finally, we're going to output this into JSON format so then we can feed this into our final node here. So just like that, in a few short moments, we actually have an entire engine that we can run specific queries on top of. So to kind of mock what this would look like, we have our validate page, and we can see here we take 2 inputs, claims data and authorization data. So I'm going to actually go here to my Jupyter notebook that I've already pre-populated with some data. So taking the claims JSON, obviously this is like one snapshot, and in this case, it's already been through an ETL process. But basically taking the claims data and the authorization data there, I can hit submit. And what it's going to do and what you're going to see is nodes 1 and 2 are going to process in parallel. And then from there, the information is going to pass through to node 3. And then upon hitting node 3, it's actually going to go into node 4 to finally do that strategic insight and recommendation piece. You can see each individual step broken down so you can quickly validate to see what your responses look like. And this right here is the final response that's going to be passed in to your end user. So obviously this is just for validation. This is just for a UI where you can see, what all the backend infrastructure code is actually going to do. So when you're ready to actually push this into production, what you're going to see is you're going to be able to save an agent. So in this case, I'm going to call it Med Insight Demo. I'm going to hit submit. And now this agent has been saved. So basically, this entire architecture pattern that we just built out has been saved in our backend, or in your specific customer provided backend. And this can actually be accessed via a single API here. So what you'll see is you have a curl URL that you can hit, or we give you a Python kind of framework to follow. So basically, pass in this function into your front end, into your back end, wherever your code is hosted. You can pass in input data parameters. So this is where that claims data and authorization requests will feed into. And we give you the specific client ID, client secret, all of that to get going. And all of this is unique to your individual agent that you just created. It's really is that simple. In a few moments, you're able to build out an entire scalable LLM backend, an entire inference layer. We have other options, not just OpenAI. We have the Mistral, the Llama 3s of the world, where you can actually host on GPU scalable instances. But yeah, thank you so much for watching this demo and signing off.